Hey y'all, Data Guy here. And today I have a really cool video for you where I want to go over how you can build your own data drift monitor with Airflow or without Airflow. And the reason why you might want to build something like this is because a model will never email you when it starts failing. It won't crash or throw an error. It'll just sit in production quietly getting worse because the world moved and the data moved with it, but the model is still answering questions about a world that stopped existing weeks ago. And that's data drift. And if it shows up in your business metrics, you've probably been already serving bad predictions for over a month. So we're going to build something to catch it early. It's a pipeline that basically takes every new batch of data, compares it against the data your model trained on, and this screams the second they stop looking alike. So we'll do drift detection with evidently, then wire it into a real DAG, add alerting, and then also put an automatic retrain on it at the end. And I'm going to do it all locally so you don't need any cloud resources or anything like that. So without further ado, let's get into it. So before we start building anything, I want to just give you a quick overview of what we're actually building. So the mock scenario here is, hey, we're running a ticket resale marketplace, and we've got a model that predicts whether a listing will sell within 24 hours. And that model's trained on a snapshot of the market that we'll call the reference data. But then every day, new listings come in, and that's a batch. So our job is to keep asking one question. If today's batch looks like the data the model learned from, if prices spike, if everyone switches to mobile, if the mix of events flips from concerts to comedy shows, then the model's inputs have drifted and its predictions are going to start quietly rotting, so we want to adjust them. And then three tools are going to do the work here. So evidently is the drift library. You hand it two data sets and it'll tell you column by column how far they've moved and whether it's a real shift or just random noise. And then Airflow is the orchestrator that will run this on a schedule, one check per batch. And then scikit-learn will show up at the very end for the retrain. And all of these packages you can see here in my requirements.txt file. And so then, basically the way the code is going to flow is we will have a batch lands, evidently compares it against the reference set, produces a drift report, which will include a full interactive HTML summary. Then the decision of, hey, is this enough drift to care about? How many columns actually moved? If not, we're going to log an all clear and we're done. If yes, we'll fire an alert, and then it will emit actually an Airflow asset, which can kick off a second DAG that'll retrain the model. And so that's exactly what we're going to build here today. So first, want to get started in the include file directory here in our drift folder. And so if we go into this config file here, this is just our central config for our actual drift monitor, and will be our single source of truth for every path, the shape of the data, and the thresholds that decide what counts as a bad drift. So here first we have our paths, include directory, parent of a parent of a line, right? This saying, hey, this is where this folder lives, and just making sure that we keep all of our data, batches, reports, models organized well. Then down here we have our different numerical and categorical columns, right? So defining the, splitting the schema, basically, we're splitting the columns into a numerical and categorical, and then evidently we'll pick a different statistical test based on the type here. So numbers like list price and seller rating will end up getting a distance test that's built for continuous data, and categories like event type and device get one that's built for proportions. So you got to make sure you label your columns correct here, otherwise your drift scores can come out meaningless. And then down here you have under our target column, right, sold. That's what our model is predicting. So we're watching that for drift too, because a shift in the outcome itself is also a very loud alarm. And so that's the model's own predictions moving, right? Like in line 59, bundles everything we watch into one list, monitored columns, everything there. And then I'll come back here down for the thresholds in a little bit about when data becomes an alert in a few, but just know that this is where we're also setting our thresholds for whether we're going to actually have an alert based on our data. Then I just have a fake data generator here, so I won't spend too much time on this, just simulating basically sold and data actions where, hey, there's new data coming in, random new data set of some information here. So, and then here I just have some options for, hey, is it stable drift? Is it our batch? Is it mild drift, a price creep? Is there heavy drift? So we can just mock a few different scenarios here to basically just show off, hey, different types of drift, and basically just assign randomly, hey, is this going to be a drifting data set or not? And that'll kind of help us show, hey, the alerts and everything downstream. But really this is just faking data, so not super important here. The first really interesting file is drift check. So here is the heart of our monitor. So this is a file that's going to be actually doing the check of, hey, is there actually drift, right? And this is, the exciting part. So the first thing we're going to be doing in this file is, telling evidently, hey, what columns are categorical versus numerical. And this is going to be the wraparound, hey, how do we actually determine which evidently set to use? And then the core of this is our run drift report, right? So these are 3 moves here where we're wrapping each data frame in an evidently dataset object, then handing it the schema from config so it knows numeric from categorical. Then we're building a report with one thing in it, just the data drift preset, which is evidently's batteries included, check every column for drift bundle. Then line 60 actually runs that current data against reference data, and that one call is the entire comparison there. And then line 66, the snapshot save HTML, this will write a big interactive report, one that we can actually open, and it's an artifact that a human can actually look at. And then we also have down here, a DAG can't read a HTML page and make a decision. So summarize boils that report down to a small dictionary. So here we're actually going to be walking evidently's results and pulling out 2 things. So the data set count, how many columns drifted, and what share of the total that is, and then a per column breakdown with each column's drift score. And then down here, all the way down on line 111, we have our actual kind of verdict score. And this is going to say, hey, drift detected is true when the share of drifted columns crosses our threshold, and that's just one Boolean here, and that's what the whole pipeline branches on, right? And remember, we set those Booleans back in that config file, and it's the hinge of the whole system. And then we have a script that'll actually put a face on it. So if I go into this scripts folder here, let me find it. So yeah, go into my scripts folder here, and then go into first report. This will go and actually build our report, right? So this is the pure Python, no Airflow version if you want to run this from the command line. So this is really just, kind of building HPL report via the command line. By default, just looking at the market shift batch, dramatic one, right? To say, hey, here's, a massive drift detection. And then if I run actually this file here, so here you'll see run that file, and this is going to build me a dataset detection drift report. So you can see here, this is just running and say, hey, these are all the drifted columns. This is the stat test it was used for it. It was a Wasserstein distance. And actually, yeah, just bring it in here so you can see the actual drift scores. Right, so this is that HTML report. This is just what evidently will produce. And then all that Python file is going, if we go back to it, all just basically just throwing this together with some Claude generated HTML. So nothing really important there, but just wanted to show you kind of what it's coming from. And this is your no Airflow version if you want a sexy report, but obviously sometimes you don't want that. You just want your downstream pipeline to know, hey, has there been drift or has there not? So now the next thing I want to go into is if we go into, or actually just kind of also in the table, the statistical tests that people talk about there, when they talk about drift, PSI, population stability index, KS tests, and other names you hear, they're just putting a number on how far 2 distributions have separated, right? So Wasserstein is just one way of doing that, right? And that's what measures how much work it takes to reshape one distribution into the other. So the bigger number, the more work, the farther the data drifted. So that's just where all those numbers are coming from. So next, I want to actually show you how you would, actually monitor this DAG. So here, and also just kind of reflecting this, right? So you can see here the detected, data drift, drift score, stat test used, and then the type too. So now how do we actually put this into a DAG, right? So first we're going to build our drift monitor DAG. So here at the top, right, just setting those same kind of package, or not package, but pathing locations. So it knows, hey, this is where you want to actually be, looking for those scripts and everything there. And everything we wrote lives in those drift packages. So this DAG will stay relatively thin, so we don't actually have to copy and paste a lot of Python code in here. And then down here, right, just creating a basic DAG body. I think the only thing notable here is params batch auto. So it's just going to automatically batch, right? And so we're also defining an asset here called ticket model drift. So asset in Airflow 3 is a named piece of data, and producing it can trigger other DAGs. So this is the tripwire to go retrain via another DAG if needed. And then we're just using the DAG decorator because it's the best way to write DAGs these days. And our first task is select batch. And so it'll read that parameter, pass a specific batch name, and it grabs that file. So if we leave it on auto, it's just going to take the newest batch on disk, since the files are date stamped and newest sorts last. If a file's missing, it fails loudly and prints the list of what's available. But it's just a nice little touch that you would actually want to use in production. Then down here under compute drift, right, this is where evidently is running inside Airflow, right? So here we're building the report file name from the run ID. So every run is going to save its own report. They'll never collab each other. And then it's also going to call the same check batch we used in the script, log the result, and return that little summary dictionary as well, which is small enough to pass between tasks via XComs with no fuss, which is really important here. And then down here, we have in line 102, our kind of decides. So this is our branch task. And it'll read that one Boolean drift detected and return the name of whatever task runs next. So send alert if there's drift, report clean if there isn't. And Airflow will handle the branch you pointed at and skip the other. And that's how a single pipeline can handle both these outcomes clearly. And then just the wiring at the bottom, select the batch, compute the drift, decide, then branch out to the two possible endings. And you've got the whole pipeline there. And then also just going back, so you know the config files here. So this is where we have our compute column drift threshold, right? So hey, if it's 10% drift, if it's over half the columns have moved, and then we also just have a random seed for random data. And this is essentially, like I just said, just how far a column has to move before evidently calls it drifted, right? So if you are deem a little bit more drift acceptable, then you just increase that number. And then that's really it, right? So now, if we go back to our drift monitor DAG, right? So drift wins the branch, and we land in send report. Two things will happen, right? So in line 107, it's just going to see the outlets, and you have the actual asset here. It's going to produce that asset, and that's the retrain trigger that's going to fire, and that's going to trigger us over to the retrain DAG in a second. And then also we're going to alert and continue so the retrain can fire downstream, because if you'd rather have the drift hard stop the pipeline or raise a failed run, you can do that. But here I just want to send an alert out. I don't actually want to cause a failure. And then we have our alert itself, which is just a notify function, which is just building a simple alert here. So just saying, hey, here's a message format alert to say the siren, which batch, how many columns move, just high level written in Slack's markup. So it's really easy to send out to something like Slack. And then send, get webhook URL, just getting a Slack webhook URL, then posting that message to a Slack incoming webhook and delivering that drift alert. You could also use Slack notifiers, but since this is just kind of a one-off, whereas notifiers I feel like are better used for more global alerting, I just chose to use kind of a more custom notification function here as well. Then going to the retrain, right? So here we have our retrain model DAG. And this is a really nice one where we have actually no schedule, but we've got a data-driven DAG. So here, this is when it's never going to run unless the drift asset actually gets updated, which is that asset from that monitor. So the only time that it's ever going to start it is that drift monitor producing that asset, which only happens if the drift crosses the threshold. So the retrain only runs when and only when the data actually broke the model. So we have a closed loop there. And then in here, our first task is just load training data. So grabbing a reference set, folding in the newest batch, the batch that tripped the alarm, right? And the model needs to now learn the new reality that broke it instead of the old world it already knew. And then retrain and re-register. Here we're doing a real, if small, scikit-learn fit. So pipeline's going to scale the numbers, one hot encode the categories, train a logistic regression on whether the listing's sold. Then line 101 is going to score it. So you get an actual AUC in the logs. It's a stub you obviously swap for your real training job. Just wanted to show you just kind of an example that would actually work locally. And then it's going to register what it's made, bump a version number, save the model artifact, append a record to a little JSON registry, and the reason for data drift detected. So you have a paper trail, and every retrain can point back to the data drift event that caused it. And then down here, obviously in production, you'd update this as well. So now if I go and reopen our Airflow UI, we can see our drift monitor DAG actually run live here. So I'll run this here, and you'll see that it's either going to report clean or send an alert based on just completely random notifications. But here you can see, hey, send alert following branch. If we go into the compute drift logs, you can see here number of columns, drift count, so all that same information, but available in my logs. Drift detected true, right? And then these are going to send out alerts to my desired Slack channel with all the information about the actual columns that moved. And then also it'll go back and actually, so if I turn this on, let's trigger and retrain this. So I'll trigger it again, and it should retrain on drift here. So just give it a second to run. And boom, now we actually have had the retrain DAG run as well. So you can see here, just got triggered by that actual data set running. So if I go and select this run, you can see here we have our asset events, right, that actually caused it. So this retrain on drift was triggered by this ticket model drift asset being updated. So that's everything I wanted to show you today. Just wanted to show you a really clean loop for detecting data drift on a regular basis with Airflow and Evidently. So I hope you enjoyed this video. I hope you have a great rest of your day. Data Guy out.